properties of different functions. The key thing that I need you as we get through this lesson and as we finish our unit is that you understand the relationships that distinguish characteristics. What is our rate of change? That is like our slope, right? The intercepts, we've talked a lot about y-intercepts. If something is linear, in a table, it looks like constant addition or subtraction. In a graph, it's a nice straight line. In an equation, it's variables to the first power. And nonlinear, a curved line, table that doesn't have constant addition or subtraction. And equations with variables other than something to the first power. Be able to communicate similarities and differences of different functions. In that when we compare a table and a graph, or a graph and an equation, or a story verbally to an equation, or a verbal story to a table, that you can still pick out slope, y-intercept, graph, slope and y-intercept, and how those, if it's linear or not. And then being able to still distinguish between linear and nonlinear. So as we take a look at this in this first one, it says, when you give two or more functions, what properties of those functions could we compare? So the key things that I want you to be able to compare for me is the rate of change or the slope. So this is on page 17 that you're writing down. The location of the y-intercept or the initial value, and the type of function. Is it linear or nonlinear? How do we compare when we're representing them different ways? This is what I would like you to put down, and so I'm going to have these two up here as you are writing. When you compare that rate of change slope in the equation, if we think about an equation, that's the m, right? If I look at an equation, that's the m value. If I look at a table, how do we find the slope? That's the change in y divided by the change in x. I still have students getting that mixed up, not just in Math 8, but in algebra still. And then if I'm looking at a graph, what does my slope look like? That's where we're using the rise over run. And when we think about that slope in a graph, that's where we have the positive slope. Remember we had the face, the negative slope. We have a zero slope. And then we have undefined. So if you think about that face, the person's eyebrows will go up and down, positive, negative, so when you're writing an equation. The location of the y-intercept in an equation, if I'm looking at an equation, that's the b value. That's the number by itself. Levi, you writing this down? Mm-hmm. In a table, this is when x equals 0, it's the y value. And in a graph, it's where it crosses the y line. So when you take a look at a graph, it's where it crosses the y line. That point. So making sure you're understanding that difference between linear and nonlinear. So when we compare them, what are we looking at? We're trying to look at each function separately. And when you look at it separately, you're trying to see, oh, what's the slope? What's the y-intercept? And then I'm going to compare and say, oh, if this has a larger slope, it is going to be a steeper line. Or the person is going faster if it's a larger slope. If I am looking at, so make sure that second part down too. If I am looking at their y-intercepts, it might be telling me that one is starting charging you more money or less money. Okay, so as we look at these different equations, tables, graphs, stories, you'll see this. The second thing is down here being able to convert the function from one form, like if it's a table, could you write an equation for it? If it's a graph, could you write an equation? If it's a story, could you make a table of it? So changing one form to the other form and then comparing it. So if you have both graphs, it might be easier to compare them. If they are both equations, they might be easier to compare. It's kind of nice. They're both written in the same form. But one of the first things it asks us is to compare and contrast their initial values. And my hint would be that instead of starting with the comparing and contrasting their initial values, because we don't know that, right? At this point, when I look at my tables, I don't have a 0 value. So you do want to have a 0 value, so please make sure you put that in. We need to figure out when there is 0 hours what they're charging us. But before we do that, we might want to look at what are their rates of change, right? So how are their hourly rates? When I look at Pete's Plumbing, what's happening from 170 to 220? From 2 hours at 220 to 3 hours at 270. How much is Pete's Plumbing going up? Pete's Plumbing is going at a rate of $50 an hour. Okay. How about House Depot? How much are they charging us for each hour? 60. So as we are looking, go down to the second one, comparing and contrasting their hourly rates, we would be able to say that Pete's is at $50 an hour, right? And House Depot is at 60. How did we get that? We took the change in Y, this is our Y value, right, the cost, over the change in X. X was our hours, Y is our cost. So knowing these two things is helpful because if I'm going $60 an hour for House Depot, if I go back 1 unit, that means how much did they charge initially to come out? Subtract 60 from 60, it's 0, right? So House Depot, they don't come out $0, right? What about Pete's Plumbing? We're going to subtract off how much? Subtract 50 because we were adding 50, so 170 minus 50 gives us a rate of 120. So what is that telling us is that when we compare and contrast their initial values, Pete's initial value is 120, House Depot is 0. Now, that's important because Pete's is less per hour, right? But when we look at it, it's $50 per hour versus 60, but their initial values are different. So if I'm asking about their starting points, right? House Depot starts at 0, on the graph. Pete's Plumbing starts up at 120. Which one is a steeper line? Which one has a bigger slope? Which one is a steeper slope? Pete's or House? Which one has a bigger rate of change? House Depot was going to be steeper. This line would be steeper, right? If I was drawing a line. This one would be a little flatter, right? Because we're not charging as much. But this one starts at 0, and this one starts up at 120 if I was going to graph that. So now we're looking at that last part, and the last part says, well, which service would be cheaper for 50 hours? So let's write an equation. House Depot's equation would be Y equals, the rate of change was what? 60x. That's for House Depot, right? If we replace x with 10, if x equals 10, how much would it cost us? 60 times 10 would charge us $600, right? They're going to come out and work at our house for a 10-hour job. We're going to go to House Depot's equation, which was this, because it was plus 0. They're going to charge us $600, okay? Now we want to do Pete's Plumbing. Pete's Plumbing, what's our equation going to be? Y equals 50x plus 120. So we're going to use x equals 50, or x equals 10, because that's how many hours. So what is our y equals? Please write this down. 50 times 10 plus 120. Everyone should have this on their paper. So 50 times 10 gives us 500, plus the 120 gives us charges $620. So when we are looking at those, yep. Why what? Because the slope is bigger, the rate of change. The 60 is steeper. That means you're going up for each hour. You're going up $60 over 1 hour. This one is only going up 50. So when we look at those, to know the steepness part, good question. The steepness part, knowing if it's steeper, that's looking at these two values, okay? Because here you're only going up 50. So when we look at these two, right, we have our two equations. House Depot is going to be $20 cheaper. And you might not have thought that because it doesn't start out at 0. So what you're going to want to do is replace the variable, just like we did up here. And if you have this work, you don't have to write the work over here again, right? This is the same work. You can just have it as you are looking at that. But that's going to tell us which one is. This one does start out at more per hour for Pete's Plumbing than House Depot. But Pete's Plumbing is going to be a less steep line. So now we're going to look at top of the next page, on page 18. We are looking at two different situations. So now, at the top of the next page, we are looking at a skating rink offers birthday party packages. Package A represents the function, and I give you the equation. So in that, I give you the equation C equals 6P plus 5. C is the cost, P is the number of people. So at 0, what do we know how many people were there in this equation? If X is 0, Y is, or C is, I guess. If P is equal to 0, we know that the number of this is going to be, if we are looking at it, 5, right? People 0, they know the cost is $5. In this table, this is package B that they offer us. If I have one person, it costs me $8, 2 is 16, 3 is 24. What's our pattern? Each time we are adding 8. So what would 0 be? 0. So this one isn't 0, 0. What is my slope? So in this one, my y-intercept, right? When it's 0 is 5, different than 0, 0. And what is my slope in this equation? How much are they charging per person? What's my slope in our equation? Should be $6, right? Versus $8 here. So as we look at those two, right? So now what we want to do is we want to compare those. So which package costs more for 10 people? So the first thing you're going to start off with is we want to look at writing our equations. So we're going to put them both in slope-intercept form. The first one was y equaled, or c equaled 6p plus 5. We're going to put 6x plus 5. Our second package, y equals 8x. Does that make sense to everyone, the two equations? Then we put in x is 10 in both. We get 65 for 10 people and 80 for 10 people. If you're like most parents and you're buying a birthday package, you're already spending a lot of money on presents and gifts and gift bags or whatever, you're probably going to go with the cheaper one, right? We'd probably go with package B, which is $15 cheaper when I have 10 people. Now, if I don't have as many people, right? If I have 3 people with my kid or 4 people, we invited people, then I might be going with package A, but it depends on how many people, right? So which one is going to be steeper if we're looking at those two graphs? Which one is steeper, A or B? B is steeper because 8 is bigger than 6. This would be a steeper graph, right? Okay, and the reason, if we are looking at that, is that 8 is larger than 6. If I asked you which one is starting higher up, okay, which one has a higher start point, higher y-intercept or start, right, then I would have package A, because it's at 5, and 5 is greater than 0 when I'm looking at that, okay? So is that making sense as we talk about these different ways of comparing them? Next page down. We are looking at comparing the functions. So it says your parents said you can sign up for a music download service to get music for your phone, and they said you have to pay for it. There are 2 companies you're deciding between. You look at their pricing below, plans below, to answer the question. So we have Danelle's in a graph, and we have JD's in an equation. Can I tell what Danelle's, what his y-intercept is? How much he's charging for 0? $20, right? And 0, 20. That's my y-intercept, right? So when I think of writing his equation, back here is a 20, right? I now want to try and look at his rate of change, his slope, right? And if I'm looking at this graph, the most common mistake that I'll have students make is that we can use definitely these 2 points, which is for how many songs? 10 songs, right? But how much are we going up? Are we going up 1, 2, 3, 4? Did we only go up 4 if we are looking at that, or how much? 5, 10, 15, 20. This is $20. So what most of you sometimes miss is you count this rate of change as 1, 2, 3, 4, and over 10. But this is 5, 10, 15, 20. You got to look at the scale. And 20 divided by 10 gives us a slope of 2. And I heard someone say that earlier, that, oh, look at here. For 5 songs, it was $30. So it went up $10 for 5. So $2 a song if we are looking at it. So now it says, which company charges more per song? So if we are looking at which one charges more per song, we would say JD's tunes, right? How much are they charging per song? 3, right? Which company has a higher membership fee to get in? Definitely Danelle. $20 versus $15. If you only had $40 to spend each month, right? Monthly service. Which company are you going to choose? So, what I would like for you to do is right behind each of these equations, put in x equals 40. Okay? Is 40 the x or is it the y?
Y.
It's the y. So you want to go something like this. 40 equals 3x plus 15 and solve. And this one you want to go with 40 equals, not 2 times 40, but 2x plus 20. In the first equation, what do you have to do as our first step as I am looking at that to solve for x, Dan? First step. 40 equals 3x plus 15. What do you have to do first?
Subtract 15.
Subtract 15. Everyone make sure you do that. Same thing down here. The first step should be to subtract 20, right? So 40 minus 15 gives us 25 equals 3x. 40 minus 20 gives us 20 equals 2x. In the first one, Abigail, what are we going to do to solve? Divide by 3. The second one, we should be dividing by 2. Here you get 10 songs, right, for $40. Here you get how many songs? 25 divided by 3? Is it 35 divided by 3? No. You're going to take, you got to borrow and subtract as you're doing that. So if we are looking at this answer, we should have Danelle's, you get 10 songs, right? JD's, you only get 8. You don't get as many songs, right? So which one would be a better for us? Probably Danelle's. Okay? So, it was not asking you how many songs, so you gotta just watch this. I still have students in our algebra right now that we're doing this line of best fit, and they keep putting the variable in for the wrong one, the x and the y. You're still gonna be doing the same stuff next year, just a little more complicated, okay? Alright, so, problem 4. We got 2 more to look at, okay? So problem 4. Your neighbor's friends have decided to have a running race down the street. Here's the information about the distance in terms of time t. So notice that they put time on our axis for x, and our distance is d. That's the same as our y. So first off, it says, Abby, we give a table of values. At time 18, she's at 70, 20, 77, right? We know that Marty is running at 5 meters in 2 seconds. And has a 10-meter head start, okay? And we know that Kristen's distance is modeled by this equation. The equation is slope-intercept one. What was her head start? Head start of 3, right? How do we know that? Because that's the y-intercept, right? Head start of 3. What do we know how fast she is running, her speed?
4.5 seconds.
4.5 meters per second when we talk about rate. So far we know this person is going 5 meters in 2 seconds. How fast is that for their speed? 5 meters in 2 seconds. That is how many meters per second? 2.5 meters per second, right? So we now have our speed of this person is 4.5. We have our speed of Marty is 2.5. So far it looks like Kristen's going fastest. But we need to find Abby's speed. So when we look at Abby's, we want to look at the change in D, right? This is our y, the change in d. So from 70 to 77, how is it changing? 7. 77 to 84, is it the same change? Yep, so 7 divided by the change in time. Okay, so this was our y, this is our x. What is our change in time from 18 to 20? It was 2. 7 divided by 2 gives us 3.5 meters per second. So, who is going fastest? We would say that. What's that?
Ted. Ted the teddy bear.
Oh, Ted is over here. Sorry. Let's do Ted too. Sorry, Miss Ted. Miss Graph. So table, 2 stories. If we're looking at Ted, Ted starts at what? His y-intercept. It's a 5 head start, 5 meter head start, right? Okay. And sorry about that. Thank you for watching. If we are taking a look at Ted, how fast is he going? He went 40 is our change going up, right? Change in y. So if we think about our slope, the change in y, or the rise, was 40, from 5 up to 45. And how much time? How much time did he take? 10. This point is 10:40.
Is it 45?
But he started at 5.
Oh, never mind.
Up to 45. So we count out 40. Okay? So his slope is at 4 meters per second. So we still have Kristen being the fastest. Okay? But we have all of their speeds written down. And then it says who had the biggest head start?
Ted.
Marty.
Oh, never mind.
Do we know what Abby's is?
2 steps.
Can we find Abby's? We can, but if you look at these, most likely Marty in this case has the largest head start at 10. His y-intercept is are spiders that are climbing on a wall. And one spider is directly, if we are looking at this, above the other one. Their distances are in centimeters traveled over time in seconds. Given below is the equation and a table. Use the information to answer our question. So, y equals negative 3.5x plus 7. And that was for Speedy. And Scooter, the spider that they've named, started at 0.4, 17.5, 211. So the first question says, find the rate of change of the spider and explain what those numbers mean in the equation. Speedy's is what? Negative 3.5. And Scooter's is what?
3.5.
Positive 3.5. One of them is going up, right? One of them's going down the wall, right? So, as you are looking at that first answer, they both have a slope of 3.5. It's just that one has a negative. So, because Speedy is climbing down, right? Speedy's climbing down. He has a rate of 3.5, and that was the negative 3.5. Because Scooter is climbing up, his rate is 3.5. What we notice is that they are climbing at the same speed, but if we are talking about, because one is positive and one is negative, they go in different directions, okay? So same speed, different directions. Then it says, find the initial values or y-intercept of each spider. Explain what it means in terms of the situation. When will the spiders meet at the same point? Do you think they will meet?
Yeah. No.
So, if we are looking at them, if they are sitting on the same wall, they actually are going to intersect. And here's how we're going to find that. So what I want you to write down is this. Speedy starts at 7. Scooter starts at 4. Okay? They are 3 centimeters apart when they started. They're moving at the same rate. And so the question is where they are going to meet. This is leading us into our next unit, which is called systems of equations. This equation for Scooter was y equals 3.5x plus 4. Speedy's equation was here. What we want to do is we want to put Speedy equal to Scooter for their equations. Okay? So we're going to put Speedy equal to Scooter. Speedy's equation was negative 3.5x plus 7. Scooter's equation was positive 3.5x plus 4. If I asked you to solve those, an equation with one variable, you know how to do that. This is going to be called our substitution method when we get into the next unit after we take our final. We are putting both of those two y's equal to each other. And do you know how to solve this from our equations of solving equations? We're going to add 3.5 to both sides. 3.5x. We are left with 7 equals 3.5 and 3.5 gives us 7x plus 4. Right? If we are looking at that, we are going to be subtracting, if we are looking at this, 4 from both sides. We get 3 is equal to 7x. And when we do that division, we are going to be looking at where that is, that halfway point.